This is part two of some inverse trig functions, kind of an introduction to it. And we are just looking for the exact value of these inverse or arc cosine, sines, and tangents. We're going to be pulling answers from most likely some of our special right triangles, and these are our restrictions. So sine can only go from a negative 90 to a positive 90, same thing with tangent, and cosine is going to go from a 0 to pi. So if we are looking to do inverse sine of negative root 2 over 2, again, the whole idea of an inverse is you're trying to figure out what angle would have given you that answer. So sine of some angle is going to get you a negative root 2 over 2. And remember that this would have came from an unrationalized 1 over root 2, actually a negative 1 over root 2. So sine is narrowed down to these two quadrants for your inverse, and so we're looking at this quadrant down here, and opposite over adjacent, opposite over hypotenuse for our sine is going to get us a 45. So we're looking at a pi over 4, but we head in this direction for our pi over 4, so it gives us a negative pi over 4. And then cosine of the exact same thing. So again, we're getting this time we're talking about an adjacent over hypotenuse, so adjacent over hypotenuse is still a 45, so we're looking at a pi over 4 kind of an answer. However, we are going to be in the second quadrant with this, because cosine is negative in the second quadrant. So, and technically it's negative in this quadrant as well, but we can't choose that quadrant, we're stuck at the second quadrant. So we are talking about a 45-degree reference angle here, and so that's going to give us 1, 2, 3 45s to get there. So it's going to be a 3 pi over 4, which is really 135 degrees. This one, we have arc cosine, which is the same thing as inverse cosine, of a negative root 3 over 2. So we are going to be again in this quadrant over here, and cosine of 30 degrees because it's adjacent over hypotenuse. So cosine of 30, so we're looking at a bunch of pi over 6s. So if we're at a 30-degree reference angle over here, that is 150 degrees. And how many 30s does it take to get to 150? 5. So 5 pi over 6. And again, if we did the same thing here, we could count that it'd be 1, 2, 3, 4, 5, if you wanted to draw it that way. And then last one, inverse sine of 2. So this would have came from if you had some sort of an equation, sine of some angle, and we're looking for it to equal 2. Well, sine only gives you values between a negative 1 and a positive 1, so there's no chance for a 2 to happen. So there's no answer to this. So it does not exist. So, trying to trick us. Alright, so that value on all these things, at least for sines and cosines, on a tangent you could get something bigger or smaller than 1s and negative 1s, but not so much on sines and cosines. You're limited to all these values have to kind of range between negative 1 and positive 1. Alright, and that was part 2 of finding an exact value for inverse trig function.